Hey everyone, this is Ade Manikanta, roll number 2201CA05. Today I'll be walking through my implementation for the assignment 10, building a fully functional pipeline homeopathic encryption system from scratch in Python. The coolest thing about this piler is that it's a homeopathic crypto system. This means we can perform mathematically operations like addition and scalar multiplication on data while it's still encrypted without even needing the private key. Let's dive into the code. Here you can see here you can see the code. What we did here is, starting with our key generation, we use the Simpic library to safely generate two large random 1024-bit primes, P and Q combining to make our 2048-bit equivalent RSA security key. We calculated N as P multiplied by Q and set our generator G simply to n plus 1. Next we establish the code mathematically identifies for the private key. We compute lambda which is lowest common multiply of P minus 1 and Q minus 1 and our mu parameter, a quick modulation invest utilization Python built-in power function wraps up our key generation securely. The encryption process, let's see the encryption process. Now let's look at how we encrypted a plain text message. To ensure symmetric security, meanwhile encrypting the exact same number twice yield difference cryptic test, we pull a random integral R. The cryptography applies the standard formula $G$ to the power of our message $M$ multiplied by our random $R$ to the power of $N$. We calculate all these modules $N power 2 power $. This returns our seamlessly randomized highlight security. The description now let's see the description process. And for the description side of things, here we take our cryptic test C and raise it to the power of lambda modulo n power 2. We then pass the result through our lx function, which safely brings it down back to the $N$ space, and finally isolated the original message by multiplying it with mu modulo n. Boom, original text is recovered. The magic. But here is the real magic of the piler. If you want to add two distinct encryption messages together, we don't decrypt them. Look at the add function. We literally just multiply the two cryptic tests together modulo. That's it. To multiply an encrypted value by a known constant as seen in the multiply function, we just raise the cryptic test to the power of the constant $K$. It's elegant and lightning fast. Demonstration and interactivity. Now let's see. To prove that this isn't just theory, I built an interactive test script. Let's run it. So here, as you can see, the automated demo instantly calculates extreme complex expression like a plus b whole into 2 plus c, processing everything entirely on the encryption data and verifying that the final descripted result perfectly matches the plain text arithmetic. If you want to play around with it yourself, the script prompts you with a clean interactive testing menu, so you can plug in your own interactives and test it on the fly, including combined complex expressions. Now let's see output. outro, and that converts everything as assignment 10. Thank you so much for watching this video.